Hello everyone, welcome to our YouTube channel. Today we will discuss about another machine learning model which is called customer segmentation. So let's discuss our workflow. So first we will import our dataset file into our collab library. So it will help us to read our data. Then after importing a file, we will pre-process our data. After pre-processing our data, we will analyze our data. So basic data analysis will help us to analyze how our data will look in our tabular form, okay? How it has tails, describe values, and so on. Then after we will use key means function, which I will explain later how it will help us in our determination. Then we will do our customer segmentation on the basis of our data, of our key means function. Then after customer segmentation, we will output our graph. So let's go to our collab and discuss our code. So first we will import our libraries. So import libraries. Then we will import our NumPy as NP, pandas as PD. Then we will import our matplotlib, matplotlib.pipenode as PLT. Then we will import our Seaborn library as TNS, and at the end we will import sklearn construct k-means. These k-means will help us for customer segmentation. So simply from sklearn.cluster shall import k-means. What is k-means? I will explain later. So k-means. So now run our cell. So after our cell, let's check our libraries. First import our file. Let's import our file main customers. Okay. Now with the help of pandas, we will read our file. So make a variable called customer. So customer is equals to pd.read underscore csv. Pass it our file path, copy, and then paste it here. So let's run our cell. Our file has been read. So now we will see our first 5 rows with the help of our .head function. Okay, so dataset analyzation. So simply use customer variable name .head for our first 5 rows. So this is how our data in tabular form will look like. Here we have 5 columns, 0 to 4. Okay, our index starts from 0 to 4. So basically our annual income and spending score are the key factors here. So we will explain them after. So just read our file. After checking our head, we will see our shape. Okay, so just make a new cell. So let's check customer.shape. So as I explain later, we have 5 columns and we have 400 rows. Okay, the annual income and spending score our has been. So now make a new cell. So let's see, is there any null value in our dataset? So customer.isNull.sum function. So it will explain, is there any null values in our dataset? So just run it. So as we have no such null values in our dataset. So we will choose our key factors. First key factor is annual income. So our second key factor is spending. So these are the factors on which our whole prediction is based on. Okay. So now we will make a variable customer dot allocate. We will use allocation function which will help us to locate our index value. So as you know, our two key factors are on 3 and 4 index. So as you know, we have 5 columns. as 0 customer ID, 1 gender, age, annual income and spending score as in. So our index starts from 0, annual income and spending score is on 3 and 4th number. This is our indexing we use. So now we will locate our key factors at the key index position. We will get their values. So we will print our x variable. So print our x variable. So this is how our values is. So first is our annual income and second one is our spending for ranges from 1 to 100. Okay. These are between these spending store is between 1 and 100. Okay. So after checking our x values, we will at location 3 and 4th. Now we will choose number of clusters. So to make our text here, choose number of clusters and WCSS, which is called within cluster sum of scale. What is within cluster sum of scale? I will explain here. So let me make the text complete. Within cluster sum of scale. So what is within cluster sum of scale? The within cluster sum of scale is a measure of variability of observation within each cluster. In general, cluster data sum of scale is more compact than a cluster data has a large sum of scale. So in simple, WCSS is inverse to number of clusters. If one is in large, the second one will be less. So these are reciprocal. If one increasing, then second one will be decreasing. I hope you understand our definition. I will explain in the graph later. So after our definition, this is our formula for our WCSS. So now we will see our number of clusters. So first, let's see, we have a cluster number 1 where plus sign P1, P explain data points, and the second C1 will scale explain our centroid. So the more the data points close to each other, so it explains that our customers at a particular point are more condensed. Means we are discussing our customer segmentation. So if they are close data points, so it explains our customer segmentation are more compact as such point. So we will use our 5 data points, our 5 number of clusters. So these are the 5 different shapes, 5 different segmentation, 5 different clusters or different segmentation of our customers. So now code our data. We will make a function WCSS. We will make it as a list. Then after we will use a for loop. Okay. So basically our number of clusters, we will iterate them. Okay. We will pass it our range 1 to 10, for example. So now we will make a variable k-means as we have used k-means there. So k-means is just a function for customer segmentation. Okay. K-means. The k-means that we are using there, import k-means, it will help us in clustering of same sort of data. Okay. So now clusters, we will give it our I variable, our I for our I ranges from 1 to 10. We will initialize as k-means. There are other initialization steps which we will explain in other videos. So now we are using k-means, so we will initialize our code, our k-means plus. Okay. So now we will use any random state. Let's say we will use 35 here. You can use any as you want, and it will affect your result according to it. Okay. Now we will fit our x data of our annual income and spending score into our k-means function. So this is our x our variable in which our k-means annual income spending score has been stored. So use it here x. So now we will append. Okay, after iterating on each segment, we will append and store it in the list. So first it initialize I cluster, then it will it will complete a loop. It will append it into WCS, then it will again go to our loop until it reaches to our 10th number, as we have planted, as we have suggested in our range. Okay, so we'll use k dot inertia is just a function for our append. Okay, so it will append our data into our list, k dot inertia into our list. Okay, WCS list that we have initialized in the very first layer. Okay, in the very first. So let's run our data. So our list has been created. So now we will plot our graph. Okay, this is the graph within cluster sum of scale. As I have mentioned before, I will explain it after coding. Okay, so basically it is as WCS increasing, our number of clusters, K means cluster decreasing. So now it's show our graph, plot elbow graph. So we will use our CNS to plot our graph, CNS.set. Then we will plot our graph which ranges from 1 to 10, as we have discussed in our loop function range 1 to 10. We will pass it our WCSS values. Okay, so range 1 ratio 10, pass it our list that we have used, we have created WCSS. So now we will make a title of the elbow point graph. Number of clusters are on the horizontal row and y label WCS values are on the vertical rows. Okay, and the y-axis. So let's plt.show our graph. So let's run our that. As you are seeing, as the WCSS values decreasing, our number of clusters is increasing. So basically, this is how our small number of clusters impact more than our large number of clusters, as we have. So now we will make a new cell. Then we will train our model, cluster model. Okay, so make a command, train, k means cluster model, underscore k means train, k means cluster model. So we will use here for only 5 number of clusters. Okay, so we will use here number of 5 clusters, as we have discussed in our video before, as video clip, as we see before. So now we will use k means number of clusters, as we have used it in our for loop. So let's see what is that. So as you know, see, just copy paste this. So paste it here. Just replace I with 5, as we are using 5 number of clusters, and choose any random cells you want. So let's say we use 5. Okay, so now make a new variable. So now we got y. We will now predict our x variable, as we have fit our k means root fit. Now we will predict it. Okay, so let's see here. As we see, we k means root fit our x variable. Now we will predict our fit variable. Okay, so k y, let's run it. So as you are seeing here, we have 5 number of clusters, ranges for 0, 1, 2, 3, and 4. Basically, index starts from 0, so we have 4, and 0 to 4 means 5 clusters. So now, with the help of, we will see our graph, we will plt graph. So first we will make a comment text here, clusters is equal to 5, which is 0, 1, 2, and 4, 3 and 4. So basically visualize all our clusters. Visualize of all clusters. So now, with the help of matplotlib library, we will plot our graph, plt.figure. The figure size should be 8 by 8 in a 1 by 1 ratio. So just you can use any shape you want, just make a. So plt.scatter. So just copy paste it for our, as we have 5 clusters, so make it 5. So just simply make cluster 3, 4, and 4, 3 and 4. So 5 cluster. So just change their color. So yellow, as in choose your own color. So we will basically use our basic colors, red, green, and let's say violet, And the third and last one is, let's say, below. Okay. So now see here, we have y0, d0, and then y1. Okay. So what is 0? And 0 is for our annual income and 1 for our spending score. Okay. 0 for our income is 1 for our spending score. So first our, as you know, we have 0. So just change them 1, 2, and 3 and 4. Okay. 0, 1, 2. So we have 5 number clusters. So each 1, 2, x is equals to 0 and y is equals to 2 and 3 and 4 and take it. Okay. And 4. And on the second hand, as you are saying, we just simply replace it. Our x is 0 or 1. Okay. So 4. And so now we have making 0 is equal y is equal to 0. Okay. And 0 spending score. Let's see us again hide this output. Spending score 1 and so on. So now after making this, we will now make a PLT centroid cluster center. Okay, make a command PLT underscore Ori has to make a command plot centroid our center variable and cluster center. We will use it for plotting our centroid. As we have used this for our number of center data points, we are now use our centroid. K means your cluster centers. Cluster centers of what? Our 0 means our annual income. And cluster number center 1 means our spending score, which is 0 and 1. And x is equal to 0 means such a size. So we will color it as our black and we will label it as our centroid. Okay. Our symbol is the spending income. Okay. So as just as you can take it as a size, as centroid should be big and our data point should be 50. So let's customer title our customer group, X label on that horizontal axis annual income against our spending score. So now just simply run our cell. As you are seeing, we have spotted our graph. As you are seeing, our centroid is black. Centroid is black, and our data points are accordingly to their correspondingly colors. So this is how our data points and centroid will look like according to our annual income and spending score. So this is how we will segmentize our data. So that's all from me, and thanks for watching our video. Thank you.